Hello, I'm Professor Rad, and today we're going to mix up some operations on signed numbers. All of our examples are going to involve integers, so we're not going to worry too much about decimals today. As a reminder, when you have multiple operations to complete, we've got this agreed upon order of operations, where first you do anything in grouping symbols, then you do anything that's got an exponent or a radical, then you perform multiplication and division going from left to right, and then you perform addition and subtraction, also going from left to right. And we can remember this using the shortcut GEMS, right? So grouping symbols first, exponents, multiply and divide, subtract and add. All right, so let's go ahead. We're going to work through 5 examples together. So hopefully we can kind of decrease the intimidation of seeing all these symbols and operations and things mixed together. So for our first operation, I'm going to write GEMS over here just as a little reminder to myself. Grouping, exponents, multiply, divide, subtract, and add. So for this first problem, oh gosh, we've got 2 sets of parentheses going on. So what I'm going to do when I do these operations, because the operations can have some like hefty steps to them, I'm going to have like some scrap paper off to the side here. So I'm going to keep the main progress of the problem here on the left, and then I'm going to have like my scratch work off to the right. So to start out with, I've got this 1 set of parentheses. So let's write that whole thing off to the side, because that's what we want to work on first. In this expression, in fact, I'm going to cover that up so that I'm not even thinking about it. And I'm just going to look at this problem here. It's smaller and easier to process. So I have subtracting and adding. So I'm going to subtract and add going from left to right. So here we have 16 minus 4. I'm just going to count down for this one since 4 is pretty small. So 16, and then we have 15, 14, 13, 12. And then I bring down the plus 8. And then for this one, I can count up to do the adding. So I've got 12, 13, 14, 15, 16, 17, 18, 19, 20. So we end up getting 20. On my main problem, I want to indicate what I did in each of these steps. So the first answer I got was 12. And that came from this piece here. And now I'm just copying everything else that was there. And then I got 20 when I added the 12 and the 8. All right. Now, I notice we have a second set of parentheses here, so I'm going to copy that problem over here. Cover this up, so I can just focus on this problem we're going to solve now. So I have 20 minus 24, and the bigger number is second, so I can't very easily do the subtraction. So I'm going to treat this like subtraction of signed numbers since the smaller number's first. And I'm going to keep the 20 the same, change subtraction to addition, and then change a positive 24 into a negative 24. So I'm using my integer rule of subtraction, keep, change, change. Now I'm going to use my rules for addition. So addition says if the signs are different, we're going to subtract the 2 numbers and take the sign of the bigger one. So I'm going to do 24 minus 20, which is just 4. And then the bigger number was 24, so I get negative 4 for that answer. So over on the main problem, I'm going to put in a negative 4. Now, when I bring down the symbols, I've got to be very careful. This negative is part of this answer. I'm bringing down the subtraction, which was not part of that answer. So a common mistake here is to just write 20 minus 4, because we forget that this negative was linked to the 4 and this minus was a subtraction, something different. Whew, okay, now we only have one operation left to perform, and that's this subtraction. So since I have a negative number here, I'm going to do the rule for subtraction. I'm going to do keep, change, change again. And since this is my last operation, I'm just going to continue to work it down here. So I'm going to keep the 20, change subtraction to addition, and change this negative 4 into a positive 4. All right, 20 plus 4 gives us 24. Cool. Let's check our answer to this one since it took us quite a bit of time to do. So let's work through and just type in exactly what's here. So my scientific calculator has these parentheses buttons to allow me to do that. So I'm going to have 16 minus 4 plus 8. It would help if I typed in the right operation there. There we go. Minus parentheses 20 minus 24. And here's hoping we get 24. Ta-da! We did. All right. Let's do 2 more examples that are pretty straightforward, and then I have 2 weird examples that we'll do afterwards. All right. So for example B, we've got in parentheses 5 minus 8, and then in square brackets, -7 minus -3. Oof, I can tell I'm going to need some scrap paper for this. I'm going to draw a line off to the side. Again, I've got 2 sets of groupings. I've got this 5 minus 8, and then I've got these square brackets. Now, the reason that these square brackets are used is because they put parentheses around the -3. So the idea is that these square brackets make it easier for us to see that those are being used to group, while this -3 is trying to avoid subtraction of a negative without those parentheses. So let's deal with this first one first, 5 minus 8. So I'm going to write that off on my scrap paper. And then I'm going to ignore the whole problem. Now, this one, I've got 5 and I'm taking 8 away. So I could do keep, change, change here. Or I could think about it, let's think about this one in terms of shapes fighting each other out. So I've got 5 circles. And I've got 8, I'm subtracting 8 circles, but since I'm subtracting, they're playing for the opposite team. So I'm going to have 8 squares. All right, the battle ensues, and we're left with 3 squares. So that means we get a -3. So over here, we have -3. And I'm going to choose to keep the parentheses, but you don't need to. And I did want to do this just as a reminder that if you ever forget a rule about how to do something, go back to the fundamentals of what it means. So I have $5 and I take 8 out of the bank. So now I'm overdrawn by $3. So whatever way was most helpful for you to think about these operations, you can always go back to that in a moment of panic. Whew, okay. Oh gosh. Okay, so now we have the second set of grouping, and that's our square brackets. So -7 minus -3. Let's cover that up because this looks terrible enough on its own. So let's do this one the same way. Let's have the teams playing against each other. So -7 means we're going to have 7 squares. And then we're subtracting. So these 3 squares are going to play for the other team. They're going to become 3 circles. Then the battle ensues, and we're left with 4 squares. So that means we get a -4. So over here in the main problem, this piece is going to turn into a -4. Now you could keep the square brackets, or I just sort of naturally went for parentheses. It doesn't matter. What is important here is that I recognize that I've got multiplication going on between these two sets of brackets, because we had a parentheses and a parentheses with nothing in between. So I've got to be careful, because if I didn't put parentheses around these, if I just put a -3 here, and then if I just wrote a -4 there, I would then interpret this as a subtraction problem instead of a multiplication problem. So something that you could do if you don't want to write these parentheses, as you write things out, I could immediately turn this into 5 minus 8, and then put a times there right at the very beginning. So I would recommend, if you're the sort of person who would write -3 minus 4, and that used to be me, start writing a times in between your parentheses that are close together, and that will help to avoid that mistake. Now here at the end, we have just a simple multiplication. So when I multiply, if the signs are the same, we get a positive, and if they're different, we get a negative. So since I have two negative numbers here, I'm going to get a positive answer. And 3 times 4, well, that's just 12. Now, you don't have to put the plus in front of your answer. You could if you want to, but you could also just write 12. So that's what I'll do. All right, let's check this one on the calculator as well. So I'm going to type it in exactly as it's written. But my calculator doesn't have a bracket button, because my calculator is like, well, brackets are just fancy parentheses. So I'm going to use the parentheses button as well for the brackets. Then I'll hit enter. Hooray, we get 12. All right, let's look at a third problem. So in this problem, I'm going to need some scrap paper again. And we've got a lot going on here. Now, there are parentheses. So remember, with our grouping symbols. So we do have some grouping symbols of parentheses written, but they're not being used to group an operation. They're being used to group a number. So we just have a -5 here, and we just have a -3 here. There's nothing inside. So we actually don't have any grouping symbols, because there's no operation inside, just a single number. Versus in the last problem, we had an operation inside that first set of parentheses. We had a subtraction to do. Okay, so these parentheses were grouped, grouping an operation, whereas these parentheses are not. We don't have any exponents, so we're going to move right on down to multiplying and dividing from left to right. So let's rewrite this one with the multiplication so we don't accidentally make a mistake like I almost did before. So because there's a 9 and then a parentheses, that means there's a multiplication there. And same thing here, nothing between the number and the parentheses means there's secret multiplication. That's just going to make it clearer to me what my operations are and make sure I do them in the right order. So we have division first, so we're going to work through that first. So that's our 18 divided by 9. Okay, and that's cover up the intimidating part and just work through this first thing. So 9 goes into 18 twice. Okay, and both of those are positive, so we get a +2. So that becomes a +2, and then we bring everything else down. Okay, take a moment to breathe after each step, because we want to make sure that we have enough air going on to get through this long problem. So now in this new line, I have times, subtract, and times. So I'm going to do this times next. So we had 2 times -5. Okay. So my rules for multiplying are, if the signs are the same, it's positive. If they're different, it's negative. So these two numbers have different signs. So we've got a negative. And 5 times 2, that's going to be 10. So this gives me -10. So this becomes negative 10. Okay, bring down everything else. Okay, breathe. Whew, okay, so now we've got a subtraction and we still have a times. So we've got to do that times next. This is a subtraction. So when I do my times, I'm going to have a positive 7 times a negative 3. Cover that up. Again, when I multiply, I want to check the signs first. Since they're different, we get a negative. And 3 times 7 is 21. Bringing it back, we've got a negative 10. The positive 7 times the negative 3 is a negative 21. And then I bring down this minus. So again, we can see it would be really easy, like we saw in, I think, the first example, to mistake this negative and the subtraction as a single thing. So you do want to be careful when you get your negative answer and keep it separate from that subtraction sign. Okay, so now that I have subtraction, I've got a negative 10 minus a negative 21. So for subtraction, I'm going to do keep, change, change. And since this is the last operation, I'm going to work it all out on this side. So I'm going to keep the negative 10, change subtraction to plus, and change this negative 21 into a positive 21. Whew, okay, so now I have a negative 10 plus a 21. For addition, if the signs are different, then we subtract the numbers. So I'm going to do 21 minus 10, get 11. And the bigger number was the 21, which was positive. So my answer is going to be positive. All right, let's check this out. So I've got 18 divided by 9 times a negative 5 minus 7 times a negative 3. Oh, good. We get an 11. All right, I know this video is kind of long, but we've got 2 more to go through, and they're not super long, so I think we can manage it. Okay, so see, just 2 numbers. Nothing fancy to worry about here, other than these vertical lines. So the vertical lines and the square brackets can look really similar. So you do want to look for the little, feet on the top and the bottom to see if that they are, if it's being used to group or if it's being used as absolute value. So absolute value kind of plays double duty. It's like a grouping symbol, but also an operation. So you do anything that's inside first, and then you find the absolute value, and then you proceed with any operations that were outside. So in this case, the negative 40 plus 13 is being grouped on the inside. So we're going to do that first. I'm adding, and the signs are different. So I'm going to subtract. Okay, I'm going to do some borrowing here. So it's a 3 and a 10. Gives me 7 and 2. So we get 27. This first one was negative, and it was bigger than the 13. So since the bigger number was negative, our answer will be negative. And then we have these absolute value bars that we want to bring down. Now remember what an absolute value does is it just makes whatever's inside positive, okay? Or whatever single number is inside positive. So this will become a positive 27. All right, and for our last example, now we have the same 2 numbers, a negative 40 and a 13. And this time we have absolute value bars around just the minus 40 and around just the 13. So we're going to do the absolute value component first. The absolute value of negative 40 is positive 40. And the absolute value of positive 13 is positive 13. Remember, absolute value is not a change the sign function, it is a make it positive. And now we have just a normal addition problem. No signs, nothing fancy, just 40 plus 13, which is going to give us 53. So one thing I want to point out through this example, zoom out a little so we can see both, is that if you have an addition inside the absolute value versus between absolute values, you get different answers. So that's something to bear in mind. You want to make sure you're following your order of operations when you have absolute value involved, and do the operation inside first before you make anything positive. So I've got a few problems that you can try out on your own. In the next video, we'll be starting a brand new chapter where we start to delve into some fancy characteristics or properties of numbers. So I hope you have a magnificent day. Take a break after such a long video, and I'll see you next time.